Hey guys, it's Sophia again. I'm back again doing some practice problems with you guys today for general chemistry. So today we are going to be focusing on chapter 7 of our general chemistry material. We did learn a lot in this chapter, but the specific thing I'm going to be focusing on for my practice problem is going to be ionization energy. I kind of picked a little subtopic in ionization energy. So for the exact problem that we are going to be doing today, and I'll be helping you guys do, we're going to be deducing valence electron configuration from the trends of successive ionization energies. So you are going to need a couple things to do this problem. The first thing you're going to need is obviously be a piece of paper. Then you're going to need a pencil just so you can write it down and do the actual problem. Sometimes it's easier if you're writing everything out and not just doing it in your head. So the third and most important thing you're going to need in this problem is going to be a periodic table. You are going to need this to look at it so you can figure out the final answer. So once you have all of your supplies gathered up, feel free to continue on to the video. Okay, so for this problem, we are going to look at this chart, and we're going to look at the ionization energies 1 through 5 on period 4 element, and this is the pattern that is given by the graph. We are just going to make a reasonable guess about which element is indicated, and for our answer, we're just going to put it with the chemical symbol that is given on the periodic table. So the first thing we're going to do is we're going to just make a note to keep in mind of something. So the thing I like to think about when I'm doing problems like this is, what are the trends on the periodic table? So in the case of ionization energy, we are going to have a couple trends. So my first trend is going to be, as we go up the periodic table, you're going to see an increase in ionization energy. This just means as we go up the periodic table of elements, the ionization energy is going to increase. And the other trend that we see is we also are going to see an increase in ionization energy as we move to the right on the periodic table. So keep those two in mind. This is going to help us later on in our equation when we are, in our problem, when we are looking at the periodic table to figure out our answer. Okay, so now that we are here, we are going to look at the graph to help solve our problem. So the first thing I like to do is look at the y and x-axis. So on our y-axis, we're going to have kilojoules over moles, and our x-axis, we're going to have ionization energies 1 through 5 listed on our graph, symbolized by bars. So in this, we're just going to be comparing the size of the graphs. So in this, you can tell that in ionization energy 2 and in ionization energy 3, there is a substantial difference in size. So this just means that a ton more energy is required for ionization energy 3 than there is in ionization energy 2. And then you can also compare ionization energy 1 to ionization energy 2. That just shows us that there's only a little bit of more energy required for ionization energy 2 than there was in ionization energy 1. So just keep that in mind during this problem. So now that we're here, I'm just going to write what this means. So this graph basically shows us that ionization energy 1 and ionization energy number 2, they are going to be our valence electrons in our problem. Sorry, in a second, you'll see that I literally can't spell electrons to save my life. But sorry about that. So now that we have that down, and I finally got my spelling right, we can do what ionization energy 3 is. Ionization energy 3, it just shows us that that's going to be our core electron, because there is that substantial difference made with the energies needed. So just keep that in mind. So now that we have that out, we can go look at our periodic table that I promptly pasted on the sheet. So we're going to go to our periodic table of elements, and we are going to go down to period 4, because that is the period that the problem originally stated that we were trying to find the element in. So I'm going to go down to the 4th period, and I'm going to go over 2, because ionization energy 3 is going to be our core electron. So my answer for this problem is going to be calcium, so Ca. That is just because we have 2 valence, so you'll just go over two elements. And that second element is going to be our answer. So once again, our answer is going to be calcium. Perfect. Congratulations, guys. We just did one more problem. And I'm very sorry about if I have any spelling and I literally can't talk.